We're now finishing that second part of C10 that we were looking at, finishing this problem. And what you should have done as you were solving this is, let's see if my gun's gonna work tonight, is you should have finished solving this by adding 1 to both sides. And if you add 1, we should get that n is equal to 28. So if we are looking at solving this, n is equal to 28 is our solution to our problem. So the question is, how many rows are in the concert hall? We would answer with 28 rows in the concert hall. Again, take a look at that equation and how we just substituted everything in that we knew. We substituted in the 2, the first term 10, and our nth term 64 to solve what was the n, which was the 28th row. You are now asked to practice, do some practice at the bottom here with explicit formulas. So as we look at this arithmetic sequence, we want to take a look at these 4 choices and trying to decide which one is a match for the sequence that starts at -5, 5, 15, 25, 35. First thing I want you to take a notice is, why are we going to choose the one we are, or why doesn't it work? So if we look at the first one, we have our -5, that's our first term, plus 10 to the n minus 1. So in this case, does it look like it's going to work? It looks like it has the same start point. And in this case, we are adding 10. So that's going to work if we look at it. The reason this one would not work is right here. We do not want to subtract 10, we want to add 10. So this one doesn't work, and a reason why would be because we want to change it to an addition of 10. Again, in this one, what would be wrong? First off, this is saying that we're going to subtract 10. We are not subtracting 10, we are adding 10. So the subtract 10 is wrong. And the other thing that's wrong is our start point. Our start is not 5. This one has a start point of 5. And we need it to be, it should be, if we were looking at that, should be -5. If we look at this one, the reason this one doesn't work is the change is not, or the difference, if we look at it, the difference is not -5. Again, if we look at this wading pool, this example, it says it's filled to a depth of 36 inches and it drains at a rate of 3 inches per hour. Which of the following gives us the depth of the water after n hours? So we kind of want to be thinking, okay, again, what's happening? So in this situation, it says we're losing 36 inches an hour. No, we're losing the 3, so this is not going to work. We are not losing, if we are thinking about that, we're not losing 36 inches per hour. So A does not work. How about B? 3n minus 36. This is saying we started at -36. So we do not start minus 36 or not having 36. So this -36. The other thing is, we are not adding. We're not adding 3 inches each time. We're subtracting it. So now we want to look at these two. And again, this one has the -36, so that's not going to work. And the one we should be choosing was D. Why? We are minusing 3 inches per hour, and we started at a positive 36. Okay, so that is our positive 36 that we looked at. We now want to kind of look at a real-world situation as we are looking at this, and this is kind of our last slide, and then tomorrow in class we'll begin looking at this worksheet and kind of finish this up, and we only have one lesson left before we get ready for our tests coming up. So if you decide to start a fitness program, you plan to run 1/2 of a mile on the first day and then you add 1/10 of the mile to your workout for each successive day. Write an explicit formula. Now remember, explicit formula is the A to the N. What does it look like? We have our first term in that explicit formula, plus the common difference to the N minus 1. Whereas when we're asked to write a recursive formula, again, you want to make sure you have these down when you get ready to take this test. You want to really right away be thinking, oh, recursive has to have the first term, that's our A to the 1, and it has to have the previous, so the A to the N minus 1, and then we got to figure out what we're doing. In this case, as we look at this situation, we know that we are looking at A to the N equaling our first term. Well, the first day we start at half a mile. Plus, each day our common difference is we want to add 1/10 of a mile. Now, you could write it in this way, or if you prefer and you don't like the fractions, same answer, A to the N is equal to 0.5 plus 0.1 to the N minus 1. We now want to look at that recursive formula. We know our common difference. What's our first term? Oh, we started out at a half a mile. Again, if you prefer this to be as a fraction or decimal, you would have had 0.5. A to the N minus 1 plus, what are we doing each day? We're adding 1/10 of a mile, so plus 1/10. Okay, so if we are looking at that, we're adding the 1/10. And again, you could have written the formula this way: A to the N is equal to A to the N minus 1 plus 0.5. And in both these cases, we have to say where N is greater than 1, or again, if you like saying the N is greater or equal to 2, because we know that we are only looking at those numbers. Tomorrow when you come into class, we'll be looking at this worksheet. Hopefully this will solidify all the stuff with sequences, explicit, and recursive formulas, how they're related to our slope-intercept, point slope, and getting us ready to finish this unit.